Hey guys, welcome to this video series on end-to-end MLOps project implementation. Now this is a hands-on project and we'll be performing all the steps which we generally follow when we build any MLOps project. So these steps would include we'll create the model, we'll modularize the code, we'll deploy it as a Flask application, we'll create a Docker file, we'll store the code in the GitHub repository, and we'll be making use of this GitHub action in order to perform this CI and CD, that is continuous integration and continuous deployment. And at the end, we are going to deploy it into the EC2 instance. So it's a complete hands-on series. I'll be taking you through each and every steps in detail. So follow with me. So ensure that you subscribe to our channel for more such updates. So without wasting much of time, let's get started. So this is how our overall project structure would look like. We'll start by defining our project name, and inside that, we'll create a folder called SRC. This is where we are going to place all the source file. This would include the model.py file. Now, this is the file which we'll be using it for creation of the model definition, data pre-processing for taking care of data cleaning and transformation, utils when if you want to have any general helper function, we'll be specifying it over there, and any.py for just the module initialization. And we'll do the same thing for the other folders as well, and we'll be building it as and when we prepare the same. And there's also a train.py file for model training, requirements for project dependencies. And this is a data folder where we are going to store the raw data. And if we have any process data, we can store it inside this processed folder. Okay, so this is a typical structure that you can note down and you can follow it in any machine learning project. And readme.md, which is the current file, which contains the general instruction about the project. All right, we have the files ready. So we've got the important train.py file. So if you take a look at this train.py file, so I'm going to import the necessary libraries. Now, since I'll be executing this train.py file in various environments, so in order to get the proper file in a proper directory, so I'm making use of this pathlib. I'm going to read the parent of this particular file, and that would be my package root. In this case, it would be Iris MLOps, and I'm going to add this package root into my system path so that I can move around freely into these various folders when I'm executing it in various environment. This is one of the common error that I would generally see with my students whenever they are doing the implementation, even though it's very simple. This is a common 2 lines of code that would be missing, which is going to mess up their code and they are unable to proceed. Okay, so ensure that you pay attention to these where you're going to add that particular part to your system path so that you'll not be getting the errors that says as package not found. Then we have already written the model inside this SRC folder. If I expand this SRC, there's a folder, there's a file that's called as model.py file. And in this model.py file, I'm going to import the logistic regression model. And over here, what it is doing is it is basically go ahead. I'm creating a class of iris classifier. Whenever someone creates an object for this iris classifier, this will instantiate the logistic regression model. That's the model that we are going to use in this scenario. And when we call fit, we'll say model.fit, and this will take X and Y, will directly perform the fit using this logistic regression model, which we have built earlier. Then the predict method is going to work just like the predict method, and this will take the single input X. Okay, that's a basic custom class that we have created. And if we have any custom modification to be done, we can just mention right here. Okay, this takes care of our model.py file, and we are importing that model, which is the iris classifier class. Then we have a function that's called as load iris data, which is under this data processing.py. Now this will take the data path. It will read that CSV file from the data path and return the data frame. A very simple data loader. The train test split, which is a straightforward function which we have from sklearn to just straight away split the data. Okay. Then I'll make use of the accuracy score, and we are going to import our configuration too. If you take a look into this train.py file, so here inside this train.py file, I'm going to get the data path, which is basically the file path variable from my config.py. So the file path is basically where exactly this data is present. So I've just mentioned the logic as how to access the data path. Then we are accessing right here. Okay, and all the other constants which I would require, it can be what should be the model name when I'm saving, and what is the save model file. So all these information that we are specifying right here. Okay, now what we are doing is, okay, we are saying this as X, like we are separating the X and Y. We'll split the data, we'll instantiate the model, we'll perform the fit, we'll generate the prediction on the test data. We are going to get the accuracy, we'll print the accuracy. Now, once the model has been printed, we are going to save the model. Let me do one thing. Instead of manually mentioning right here, I'll make use of the value inside this config.py file and will refer to it. I'll say config.model name. Okay, I'm going to save it inside this specific location. So when someone comes over here and executes this train.py file, this is going to perform the training and save the model inside the folder of model. So I have already executed last time. So there's a iris underscore model.joblib is present. I'll just delete it. So now if I execute this train.py file, the script should be executed and we should be able to see this train model inside this model folder. Let's do a quick validation. I'm going to launch the terminal and I'll say Python train.py file. So I can see the accuracy as 1%. That's pretty good. If I expand this model, see there's a model file that is present, that is iris model.joblib. Now, when I'm generating the prediction during the deployment, I'll have to make use of this model file, load the model, and then generate the prediction. That's a high level flow that we are looking at right now. Okay, so we have built the model file. Now, apart from building this model file, we have also created few other things as well. There is something called as app.py file. So let's understand what exactly is this app.py file. Here, this app.py file is going to create the Flask application. Now here in this case, we are specifying the file path and we are getting the saved path right here. Then we are going to load the model from that saved path. This is going to create an object of Flask. And if someone calls the predict path, okay, in the method of post, we are going to extract the data, we'll generate the prediction. And once we generate the prediction, we are going to generate the output in a JSON format for the prediction. Okay, and we are making use of the port of 5000. So for the demonstration purpose, my 5000 port is being used. So what I'll do is I'm going to set the port as 5002 and we'll do a quick validation to see if this is actually working or not. I'll say Python src and app.py. When I press the enter key, it says it's already running in the port of 5002. Now, if I go ahead and make a call right here, I should be able to generate the response. Let's do a quick validation. So I can test it with the help of Postman, but what I can do is I can directly run the curl. Okay, I've noted down the curl. So I'm going to mention it in this format. I'll say curl and the port is 5002. And if I press the enter key, see, I'm getting the prediction as Setosa. That means I'm able to send in the new data for the port of 5002 for the predict, and this is basically a post request, and I'm able to generate the response. You can also like make use of like the Postman or other service in order to do the testing to see if your application is working or not. So what we have done as part of this video is we have actually perform the activity of creation of the machine learning model, and we have modularized the code, and we have also created a Flask application which will take 4 inputs and it will generate the output, which is basically the class to which the given values would belong to. So that's the current activities that we have done in this video. In the next video, I'll take you through as how we can create a Docker file and do the rest of the stuff of our MLOps. Okay, guys. So with this, we come to the end of this video. Now, if you have got any question, please let me know in the comment section. And if you're liking this content, I'm sure you're going to love our course on MLOps Bootcamp and MLOps with AWS. which I've got an opportunity to create with Manifold AI Learning. Do check out the courses. And if you want to learn with me on live, so do check out the live session pages in the Manifold AI Learning too to participate in the live session with me on the Manifold AI Learning. I'll see you next time.